Hello children, we are starting off with scalar product of two vectors, and then we're going hopefully to talk about work being done by varying forces, and then we will end our video with Hooke's law, which is work done by a spring. Okay, so we kind of already talked about the scalar product of two vectors because we were talking about that with work. We know that work is equal to the force, whatever applied force it is, and then it's going to be the cosine of that times then the displacement. So scalar product is just the product of two vectors. So the scalar product is just the product of two vectors, and we're going to write that as A dot B. We also will call that the dot product. So A dot B is equivalent to A, the magnitude of A, times the magnitude of B, times cosine theta. And theta has to be the angle between A and B. So I like to think about scalar product or the dot product as this B cosine theta is a projection onto A. So when you find A dot B, you're finding A, and then you're also finding a portion of A because that's going to be just the projection of that B cosine theta onto A. Okay, so same thing. So we use scalar product whenever we're doing work because we can apply that to work. So instead of writing work is equal to F cosine theta times displacement, I could also just say F dot displacement or delta R because they represent displacement as R in your book. Okay. Okay, scalar product follows a lot of properties. It's commutative. It will obey distributive law of multiplication, pretty much follows everything else. If A is perpendicular to B, let's talk about that. If A is perpendicular to B, then that means that the angle in between them, theta, so if A and B are perpendicular, theta is going to be zero. The scalar product is going to be 0. And that's because theta would be 90 degrees and cosine theta is going to give me 0. So if ever I have A perpendicular to B and I'm thinking about the dot product, it's always going to be 0, or that scalar product. And that kind of helps us too when we add in the unit vectors, the I roof, J roof, K roof. If they're parallel and they point in the same direction, then theta would just be equal to 0. So ultimately then magnitude of A and B is going to be my scalar product. If A and B are parallel but in opposite direction, then theta is going to be 180, so then it's just going to be a negative amount of, if we're thinking about work, it would just be a negative amount of work. So the scalar product is going to be negative when my theta is in between that 90 and then 180. Okay, let's think about this in terms of unit vectors. If I have I roof dot I roof or J roof with the scalar product of J roof, or the scalar product between two K roofs, all of those are equal to 1. Versus if I have I dot J or I dot K or J dot K, what does that mean? I dot J is representing that I'm thinking about I as X, J is Y. X and Y are separated by 90 degrees. So because they're perpendicular to one another, I'm always going to get a scalar product there of 0. However, if I'm thinking about 2 in the X direction, those unit vectors is going to give me a scalar product of 1. Okay? So if we use component form with vectors, which we will probably do in a lot of these problems, then I can find A by doing, I may give you this. I may give you A and I may give you B. And that's going to be shown as the magnitude of A in the X direction plus the magnitude of Y in the, magnitude of Y and then with my J roof to designate that it's in the Y direction. Magnitude here in the Z direction, and I'll signify that with K roof. I may give you B in the exact same way. So how do I find the scalar product of A dot B? I can find that by taking AX times BX, adding it to AY times BY, adding that to AZ times BZ. Okay, and we're going to do an example of this here in just a minute. So we said, I just want to make sure that we write this down too. A lot of times on these problems, they ask you to find the angle in between the two vectors. So A dot B is equal to AB cosine theta. So if I'm asking you to find theta, it's going to be inverse cosine of A dot B over the magnitude of AB. Okay, I want you to make sure that you include that and write that down for me, just because a lot of times I will ask you to find that angle in between. So if we were to ask you a problem, or if you were to see a problem like this, what would it look like? Let's do the first one together. That first one says the vectors A and B are given by A is equal to 2I roof plus 3J roof, and B is equal to a negative I roof plus 2J roof. Determine the scalar product, and then find the angle between A and B. So first thing, I just want to find A dot B. I just want to find that scalar product. So I can do that. A was equal to, let's just rewrite it out, 2I plus 3J. And then B was equal to a negative I plus, I think that was 2J. And let's do the roof side.